Welcome, and thank you for standing by. At this time, all participants are on the listen-only mode. After today's presentation, we will conduct a question-and-answer session. If you would like to ask a question, please press star 1. Today's conference is being recorded. If you have any objections, you may disconnect at this time. I would now like to turn the conference over to Mr. Paul Gilman, so you may begin.
Thank you, Julianne, and welcome everyone to the last in the series of SAM webinars this month. We'll be posting recordings to this and other webinars on the learning page of the SAM website down toward the bottom. And we're also planning to hold another set of webinars later on this year, and so you can check out the webinars section down here to see the schedule, which we'll post when it's ready. And then here's the links to the recordings of past webinars. So today we're going to be talking about the SAM Software Development Kit. And sorry for the late start. I think we're having some trouble with folks getting the call-in number, but hopefully everyone's online and on the phone as well. So I'm going to talk about what the SAM SDK is and give you a list of examples of how some folks who are aware of are using the SDK. And then I'm going to go through the SDK contents and go through a couple of examples so you can see the SDK in action. This is going to be sort of a basic introduction to help you get going with the SDK. I'm not going to go into a lot of detail about building specific models. So first, we need to take care of some acronyms. SAM, of course, is the System Advisor Model, and I'll be describing what each of these are as I talk through this session. The SDK, that's a software development kit. That's a generic term, not specific to SAM. And then, likewise, Application Programming Interface, the API. And then SSC, that's the SAM Simulation Core. And then SSCdev is a development tool that's included in the SDK. And then LK stands for Language Kit. It's the name of a scripting language that we use in the SSCdev tool. So what is the SDK? It's a set of tools that gives you access to SAM's API so that you can write your own programs and make calls to the SAM simulation modules. So you can run simulation modules either individually or group them together to model a project or a system or a project. And when I'm using the term system and project here, a system is a renewable energy system. So that's like a PV array with inverters and so on would be a system. And then a project would be if you ran modeled that system with a financial model to come up with a set of financial metrics. So the project involves a financial model in combination with a system model. And you can set inputs, set the value of input variables for the modules, run simulations, and then read results generated by the modules. And the reason you'd use the SDK would be either to automate a repetitive modeling task. So if you may have an analysis that involves simulating hundreds or thousands of different systems, in different locations or under different modeling scenarios. So with the SDK, you would be able to write your program to automate that. Or you might want to use the SAM simulation engine with your own user interface instead of using the interface that is available with SAM. That might be for either a desktop application or a web application. One important point is that the SDK doesn't give you access to the code in the modules. So you can't modify how SAM simulates the components of the system. That remains a black box. So the API gives you access to the inputs and the results and lets you run the modules, but you can't modify the code within them. So this is the role that the SSC, the simulation core, plays in SAM. So SAM is basically a user interface with a bunch of code that makes calls to the simulation core. So you've got input pages in SAM where the user types in numbers, and then the code in the user interface passes those values to the appropriate modules and the appropriate SSC modules. You've got simulation control, so that's code in the user interface that runs the simulations, and we've got things like parametric analyses and so on that can run multiple, make multiple calls to the simulation modules, and then the results pages in the SAM interface, which display data that is generated by the modules, and then the SAM user interface basically has a set of pre-built systems and projects that are combinations of SSC modules. And so you choose, if you're familiar with SAM, you choose, the flat plate PV model option. So that groups a set of SSC modules to represent a complete PV system. And then the SAM interface has something called Excel Exchange that allows you to populate SAM inputs from an Excel workbook. And then there's the SAMUL scripting language, which is a sort of a little programming language within the SAM user interface that lets you set input values and run simulations and read results from within the SAM user interface. So that's sort of how the SSC fits into SAM. And just one clarification about that is that there's actually two layers of simulation modules in SAM. One is Transys-based. So Transys is a simulation platform that SAM uses. Right now it has two different simulation platforms: the SSC, which is a native one that we've developed for SAM, and then Transys, which is a commercially available modeling platform that SAM used to use entirely, but now we're in the process of translating the Transys components into SSC. So eventually, SAM will look like that, but for now we've got these two layers. And so that explains why not all the technologies that are available in SAM are available through the SDK. The CSP models, we're in the process of translating the SSC, and we're doing the testing now. So in future versions of the SSC, those CSP models will be available. So when you use the SDK to access the API, to use our acronyms in one sentence, you're basically stripping away all that other stuff that's in the SAM user interface, and you get to access the SSC directly. So you write a program that sets inputs, runs simulations, and reads outputs from simulation modules. Before I get too carried away here, I should mention that the operator said we'd have a Q&A session at the end, which I plan to have time for. But if you've got questions in the meantime, please feel free to use the Q&A little window here and type your questions. And I've got colleagues standing by monitoring those questions and answers, so they'll type responses. And I'll also check in periodically to see if there's anything I can answer for everyone. All right. So I want to introduce a couple of SSC terms that we use in the documentation. I've been talking about modules. So a module is a chunk of compiled code. As I mentioned, that stimulates a system component or a financial model, or there's a couple of modules that are sort of utility modules that do, that are help out with modeling, and then your code combines modules to build a system or a project model, and we use the terms. I think the documentation uses the term compute module, I like to use simulation module. They're just different ways of saying the same thing. And then there's a data container, and that's a group of variables used by the modules. So we'll be seeing those as I'm showing you the SDK. So just want to make sure you know what I mean when I talk about module and data container. Here's a list of the SSC modules that are in the current version of the SDK. This list is from the documentation, so you don't need to worry about reading all this here, but I just want to give you a sense of how many modules are currently available, and we're adding more as we speak. The CSP modules and so on will be added soon. So this is an example of what modules you would use to model a PV project using what we call the flat plate PV model in the SAM user interface, combined with the residential financial model. So the PV SAM V1 module, that's the flat plate PV model. That's different from the PV watts model. The PV SAM V1 models the module and inverter as separate components. And then there's this annual output module that basically converts the output, the hourly kilowatt-hour output values from the PV SAM V1 module into the values that the financial model needs. So it applies some adjustment factors to those hourly values, and then fills up the annual value, and calculates a table of annual output values that gets fed into the utility rate model, and the cash loan model really. So the cash loan model is the residential cash flow model, and then the utility rate model is module, I should be saying, is the module that applies the retail electricity prices, so the utility rates. So to model a residential PV project using the API, you would need to combine 4 modules. Here are some examples of companies that have implemented, have written programs that use the API, and I'm sure there are many more out there. These are just ones that we are aware of, and I guess one that I didn't put on there is the NREL PV watts model. So the web version of PV watts. There's a new version in beta test right now. That runs the SSC API in the background. Okay, I see a question here. We don't have plans to enable third-party simulation modules through the SSC that I'm aware of at the moment. Maybe Aaron can follow up with that by chat window. These are modules that we're developing at NREL as part of the SAM project that we are sort of making available through the API. Okay, so what's in the SDK? I'll show you the SDK in a moment, but let me just review what's in it before I do that. So there's the API. So the native the API is a C API. We call that the native C API. So it's just a header file. And then there's documentation. There's the SSC guide, which is a PDF file that describes the SDK. And then there's a set of code examples and comments in the code examples that are all part of the documentation. And there's also some README files in there. So the documentation comes in different parts of the SDK. And then there's the SSC development tool, SSCdev, which is a really useful way to become familiar with the modules that you're planning to use in your models, and it comes with a scripting language, so you can actually build your own models within this SSCdev tool for testing. And then there's a set of SSC libraries for 3 different operating systems: Windows, OS X, and Linux and then for Windows, there's 32-bit and 64-bit versions of the libraries. And then we also have a set of language wrappers. So if you don't want to write your program in C or C++, then we've got wrappers for C#, Java, MATLAB, and Python. So how do you get started with the SDK? I think most of you, if you're eager programmers, want to implement your model in your development environment. So you want to jump right in. But I'm going to throw in a few steps before you get to that point. Once you've kind of figured it out, it's pretty straightforward to work with the API. But there is a learning curve. We've written this SSC guide. It's not very long. It has some examples that you can walk through. So I think the first thing you should do after you download the SDK is work through the SSC guide. And then once you're kind of familiar with the SDK, then you'll need to set up your development environment in whatever language you're programming in. And so if you're working in native C, there's some instructions about that in the SSC guide. If you're working in one of the other languages, there's also instructions in the SSC guide, but then there are additional files that you'll need to look through to get everything up and running and tested. So that number 2 is not an insignificant step. You'll need to make sure that you've got your programming environment set up to interact with the API. And then what I would recommend doing before you start programming away is to build and test your model in SSCdev. I'll show you how to do that. The value in building your model in SSCdev is you can isolate any problems that you're having to the API-specific issues. So, otherwise, if you start writing your program in C and you're having trouble, it'll be a little harder to figure out whether the problem is with the way you've written your code or with something about how you're talking to the API. Then once you've built and tested your model, so you've got you can use the LK script to build your model, hook up the modules, get the results you want, make sure that things are looking like what you expect, and then you can take that LK script and translate it into your language to implement it in your own model. So working with the SDK requires trial and error. This is what happened when I Googled trial and error and searched for images. You should expect to spend some time making mistakes. Hopefully they won't result in you're getting snapped by a mousetrap. But just want to make sure you are all aware that there is some effort involved in learning to use the SDK. Okay, so next I would like to show you the SDK. So when you go to the SAM website, here's the SAM website, and we've got the SDK menu there. If you click SDK, that gives you a description of the SDK, and then when you log in, you'll see a link here to download the SDK. It's a zip file. And when you download and extract the zip file, then you'll end up with these folders and files. So we've got, this is the API itself, the C API, the header file, and then the SSC guide. That's your starting point. That's the manual for the SDK. And then the LK guide is a reference for the scripting language, the SSCdev scripting language that we'll see in a moment. So let's have a quick look at the guide here. So it starts off with some general overview stuff, but section 2 is a basic example in PV watts in C. So you can, if you just walk through that example, you'll have run the API. You'll have run a program in C that communicates with the API. So I just wanted to show you what that looks like. So I have set up the min-GW C compiler and so on that's described in this example. I'm smart enough to make this readable. So I'm basically going through the steps here in section 2.7. And so if I go to the SDK, there's a bunch of folders here. This test folder is one that I created before. That's not in the SDK. So I have a 64-bit version of Windows. So I can run the 64-bit SSCdev and libraries, but my C compiler is 32-bit. So I'm going to go to I'm going to use the 32-bit version of the libraries for my test of the C code from the user guide. So I'm going to create a little folder here, and then the instructions tell me what files I need. So I'm going to put all those files in the same folder. I need the DLL. That's the library here. I'll put that in my test folder. And I need this example C code, example 1 PV-watts code, and I also need this Daggett weather file. So those all need to be in the same folder. And so there's the list of things that says must be in the same folder. And then I need to compile my C program using the SSC32 DLL, and I'm going to compile it into a program named pvwatts.exe. So let me do that. Find my command window. First, I need to let's. Okay, so you get to watch trial and error in action here. Okay, there's my folder. And if I've got everything in there, there's the weather file. And I need the API. I need to add the header file in there. So let me put a copy of that in there. So I'm copying everything, so I keep my original SDK files intact. All right, so now I think I have everything I need. And then I'll compile the program with my recompiler. What is that called? Example 1, pvwatts.c, and then SSC32 -o pvwatts. Okay, and that looks like it did something. So then I can try to run it. pvwatts.exe is the name of the program, and then I'm going to use this command line load option to load the weather file. Oh, I get an error. It says the program can't start because SSCDLL is missing from my computer. Well, I happen to know from past experience that if I change the name of this file from SSC32 to SSCDLL, and the file that the error message said it was looking for, and then run it, that it works. Okay? So trial and error. Read your error messages and scratch your head. That one we actually is documented in the SSC guide, but you may come across similar little quirky things as you're working with the API. We can take a look at our C program. to see what it's doing. So this is a example from the SDK, and this particular example is explained in the SSC guide. Here's our main function, and we're basically setting the value of the inputs. You have to set the value of all the inputs, and a lot of these modules have lots of inputs. So that's a lot of the work that you're doing, at least lines of code that you're writing is populating all these, or setting the values of all these inputs. And then we're creating our module and running it, and then getting the hourly AC output from it and adding them all together to report the total annual output. Okay, so that's a simple example of running, calling the API from a C program. Now next I want to show you the SSCdev tool. So I have 64-bit Windows, so I'm going to run the 64-bit version of SSCdev, but I could run the 32-bit version, and then if I was on a Mac and knew how to work around a Mac, I would find the SSCdev for the Mac is there, and then we've got one for Linux as well. Okay, so let me run this. All right, so this is SSCdev. This is the development tool that I recommended using for building your models before you start programming in your own language. We've got 3 tabs here. There's the module browser, data container, and script editor. So hopefully you know what a module and data container is now. Here's a list of all the modules that are available. And when you click a module, the table here displays a list of all of the module's inputs and outputs. So these are the SSC inputs are listed first, and then the outputs. And then there's a few different data types that the API uses. So each variable has a data type and the variable name, and then there's a little description of the variable, units, and so on. So you can generate these kind of lists also from your own programs using the various functions that are available through the API. But SSCdev is kind of a quick way to visually get a list of these of the inputs and outputs of each module. Now the data container doesn't come into play until you're modeling something. So the data container is the group of variables that you're using in your model. So your model consists of one or more modules, and then a data container that stores the inputs. So if we were to run this example that's in this C program in SSCdev, then we would choose the PV-Watts V1 module, and then we have to set the values of all these inputs. So I can just kind of copy them from here. So you see this is where we're setting the values of the variables in the C program, and the variable names are the same as the ones that we see here. So file name is here, and here's file name. So if I go to the data container, and I add variables. So file name, to give it the same name that it has that it shows in the module browser. That's a string, a type string, and then I'm going to assign it this Daggett weather file by clicking file here. So this variable is called file name. It's of type SSC string, and then it's got a little button here that allows me to load the string value from my Windows browser. Okay, so there's my first variable, it's file name, and there's its value. It's a string with the weather file path. And then let's see. The next one is system size. It's 1.0, so let's add system size. It's a number, and it has a value of 1. 1.0, I don't think it matters here. And then D rate, and it has a value of our friend 0.77. And then track mode. So these variable names have to be spelled correctly. Track mode is 0. And I'm just reading the values from our example here. And then tilt. And 20. And then azimuth is 180. Okay, so that seems to be all of the input variables from our C program. So I should be good to go. My data container contains the input variables for the PVWatts module. So I go to Module Browser and choose PVWatts V1 down here. Where did it go? I'm sure you're all yelling at me. It's right there. There we go. All right, PVWatts V1, and then I click Run. Something happened? I don't know. Let me go to the data container. Okay, the data container now has all this other stuff. And what actually happened is a little unclear. There's all these 8760 values, DF, DN. So these are values from the weather file. And I should have had to run the weather file reader function first. Its input is the file name. Notice it's the same variable name as file name. So if I run the weather file reader module, it will take the file name from my data container. File name is here. So it'll read that file name, and then it should generate all of these outputs, which are the latitude, longitude, and then the hourly radiation data and weather data and so on. And that populates the data container. And then I can go back and run the PVWatts module, because it requires these as input. At least it did the first time I ran it. So I'm not sure how clear I was about this, but basically what you do is if you want to use the module browser to actually run a module, is you find the list of the show the module. So we're showing the PVWatts V1 module. Look at its inputs variables, and then you have to assign values to each of the input variables in the data container. And then once you've got all the input variables assigned values, then you can run the module. So the main utility of the module browser here is just to look at these lists of inputs and outputs in the table. The run function doesn't work that great because you can only run a single module at a time. So where the SSCdev becomes really useful is this script editor. So this is where you use the LK script, and we've got the reference manual that explains the script, that scripting language. We also have some sample scripts. So here's one in the SDK examples folder. This runs the flat plate PV model with a residential commercial financial model. So this here's the script, and you can see that we're doing a lot of setting of values of inputs, including some that are big, complicated matrices. And then here's the inputs for the utility rate module that sets the retail electricity prices by the hour. And then here's inputs to the financial model, incentives, and so on. lines and lines and lines of code assigning inputs. And then down here is where here we've got a little algorithm to size the array to assign the number of modules per string and number of strings in parallel and inverters. So you could write your own fancy sizing algorithm here. And then more inputs, and then here's where we run the cash loan module. Let's see, run. There's where we run the flat plate PV module. We get some results. Then we run the annual output module. That's the one that converts the hourly outputs into annual inputs for the financial model. And then we run the utility rate module. And then we run the cash loan module. And we're setting values of inputs before we run each module, of course. So that's kind of what the script looks like. If we run it, we get some the results down here in the console, and there are these numbers here. What are those? I know outline is the function for displaying stuff in the console, so I just searched for outline. Oh, that looks like it's the number of strings in parallel. So let me just add then modules per string. And then number of inverters. Okay, so you can kind of experiment around with these examples to get a sense of how things work. So now you can see what those numbers are. Okay, so that's SSCdev. Oh, and one thing I'll show you is when you run this script, then the data container gets, these are all the variables that are used by the script. So we've got all those input variables are there, and if you double click it, then you can edit it. If you check it, then you can build a table of these various values. For 8760, variables that have 8760 values, so arrays of 8760, like this AC net variable, you can, if you check it and then click time series graph, then you can plot the data. So that's another benefit of building your model in SSCdev is you've got these tools for displaying your variables, so you can kind of look and see, make sure that the model is doing what you expect it to do. And again, this is all described in the SSC guide. All right, let me see, like no questions. Okay. Then the last thing I want to show you then is an example of using one of the language wrappers. So I'm set up to run Python scripts on my computer. So I'll show you a Python example, but things are somewhat similar for the other languages. So in the languages folder of the SDK package are a set of folders for each of the languages for which we have wrappers. So I'll look in the Python one. And there's a bunch of stuff in here. These are all mostly sample scripts. The API, SSC API.py, this is the translator that translates the C API into something that Python can understand. And it has some test runs. So if you run this if you run this program, it'll generate, let's see, it runs a bunch of modules here. So it's running this SIMTest function, which is defined up here and calls a bunch of modules. And if you run it, it just looks a whole bunch of numbers go flying by your screen. But you can go to the SIMTest module and comment out some of the, run one module at a time so you can kind of see what's going on. But this is it's probably a good idea to run this test module once you've got your development environment set up. So once I've got Python set up running on my computer, according to the instructions in SSCdev, I set it up in a way that it's compatible with the Python code in the SDK, and then I run this test code. So let's see. I want to go to samples, or no, languages. And then Python. Okay, and then I think I do it like this. So I'll just run that test one, SSCAPI.py, and then it's doing a bunch of stuff. And then at the end, I think it says that things are okay. There's all these outputs, or there's too many to fit in this little terminal window I've got here. So when you're getting started with one of the language wrappers, you'll want to spend a little time with this test with the API file, and like I suggested, you can disable some of the modules to run them one by one, so you can kind of examine what's going on one by one, and then that'll help you build confidence that things are running as they should. And then you can start playing around with some of these sample programs. So here's one, PBSAM v1, that runs, that's similar to the C example that we saw, and that we saw in SSCdev. So if I run that, Python PBSAM v1, then modules per string. That looks familiar from the LK script version, and then I can go, I can modify things in the script and see how they impact things. So so rather than starting from scratch and trying to build something on your own, I would suggest starting with one of these sample code. That's, if you can find a sample that's similar to the kind of system you want to model, then you can start with it and modify it and experiment with it, and then kind of build up your own code from that. And again, I recommend testing things in SSCdev because it's a little bit easier to see what's going on with your with the variables in your modules. So for the other languages, we've got well, this sort of has a structured has a bunch of modules set up, so more object-oriented setup, I think. But I think this is the test script for MATLAB. I don't know about MATLAB, so I shouldn't be talking about it. But my point here is just to point out that you've got that API file to run as a test to get you going. Okay, so that's what I had to talk about. I think I'll open up the floor for questions now if there aren't any typing. So
thank you. At this time, if you would like to ask a question from the phone lines, please press *1 on your touch-tone phone. You will be announced prior to asking your question. To withdraw your request, you may press *2. Once again, to ask a question, please press *1. Moment, please. I do have a question from the phone lines. One moment.
Great.
Mr. Waite, go ahead, please, with your question.
Thanks. This is Paul Waite speaking. I had a question about the required inputs as opposed to optional inputs, and if there's any way that you can discern whether they're required or optional in the SSCdev.
Yeah, so let's see. Let's look at the PVSAM v1. Let's see. There's a field. My screen is too little here, but there's a field way over here somewhere. So this require column shows you that information. You know, so if it's got a star, then it's required. There's a key for what all of this means in SSCdev. I think optional is here with the default value. So does that answer your question?
Yes, that's perfect. The required column is exactly what I was looking for.
Great.
Thank you. Once again, if you would like to ask a question, please press *1. Not showing any other questions at this time.
Okay. Let's see. I just want to point out in the documentation, here's a discussion of required variables. And what those various flags mean. And then there's also this API reference at the end of the manual that lists all of the functions and what they do. Okay, I've got a question from Stephen Frank. Been working on some wrappers for a MATLAB API. Yes, some of these may be useful to others. Are there plans to allow end users to contribute suggestions for the API? We definitely welcome users' suggestions and feedback and so on. You can use the support forum to do that. You can also, it's a little tricky, but you can attach files to your posts on the support forum. But you have to do that. You have to attach attach attachments to or attach files to your original post. So here's a discussion that I think is yours. And if you edit your post, if you log on and edit your post, your original post, you can attach stuff to it. And if we start getting a lot of suggestions and people wanting to post sample codes and so on, then we may sort of expand the SDK page here to make it a little bit more interactive than it already is. But the short answer to your question is yes. Any other questions?
I'm not showing any questions from the phone lines.
Aaron, did you want to add anything? Aaron Dobos is sort of responsible for developing the SDK.
Hi, Paul. This is Aaron. I don't have anything to add at the moment. I think you did a great job covering the introduction to it. And the CSP models, the concentrating solar thermal power plant models that are available in SAM, those aren't yet available as part of the SDK. We're working on adding those, and we hope that they'll be available in the relatively near future, within the next year or so. But But for now, I believe all the other models, financial and system performance models that you can run via the SAM user interface, you can also run via the SDK.
Great. All right, well, maybe wait another minute or two in case people are still thinking about questions.
Again, if you would like to ask a question from the phone lines, please press *1.
One thing that I would also add, this is Aaron at NL again, is that the SDK, like there are a lot of features in the SAM user interface for accessing online databases, such as the incentive database or the utility rates, or we have those databases of module parameters and stuff within the SAM user interface. Those databases aren't accessible via the SDK. The SDK just does the calculations on the inputs, so it would be up to you in your application to obtain either module parameters from a database or connect to one of the online web services to get incentive data, and then take those results and move them through as inputs to the calculation engine or the SAM SDK. So just a little bit of distinction. Sometimes we get questions whether the database is part of the SDK, and in its current design, it's not.
Thanks, Aaron. Any questions?
Showing no questions at this time.
All right, then. We will be posting a recording of this session in the next day or so whenever we get the file. So thanks, everyone, for participating. And again, check in on the learning page of the SAM website to find out about future SAM webinars.
Thank you. This concludes today's conference call. Thank you for joining, and all parties may disconnect at this time.